Good morning, students. Welcome to chemistry class. We are doing chapter S block elements. In this video, we will discuss about reducing nature of alkali metals, reaction of alkali metals in air, reactivity of alkali metals towards water, and then affinity for oxygen. Alkali metals are strong reducing agent. In my previous video, I have discussed electronic configuration of group 1 elements. We know they have one electron in the valence shell and have very low ionization energy. So by losing that one electron which is present in the valence shell, they can acquire electronic configuration of the nearest noble gas. So as they can lose electron easily, so alkali metals act as a strong reducing agent. Variation in reducing nature down the group. Ionization energy decreases down the group, and in detail in my previous video I have discussed that why ionization energy decreases down the group. Now if ionization energy is decreasing down the group, it means that tendency of an element to lose electron will increase. So, the reducing nature increases gradually in the group from lithium to cesium in free state. But when we talk about in solution, when we talk about oxidation potential, it is observed that lithium is the strongest reducing agent among all the alkali metals in solution. So, it looks very surprising. We know that lithium have high value of ionization energy among all the alkali metal, but on the other side we have just mentioned right now that it is the strongest reducing agent because its oxidation potential value is maximum. Now why this is the case? Why actually it is acting as a strongest reducing agent? Actually, ionization energy is the property of an isolated atom in gaseous state, while oxidation potential is concerned when the metal atom goes into the solution. So when we talk about ionization energy, so in that case, simply your metal in the gaseous state is ionized. But when we are talking about oxidation potential, when we are talking about in solution, actually 3 stages are involved. You can see here. In first stage, sublimation is taking place. Second case, in the gaseous state, you can see ionization is taking place. And in the third stage, you can see that hydration, that enthalpy of hydration is involved, that energy is released due to hydration. Now, we know that small the size of the cation, more will be the hydration energy. Now, out of all the alkali metals, lithium has the smallest size. So, the hydration energy released will be maximum. So, we can say that lithium is strongest reducing agent or has highest reducing power as compared to other alkali metals in solution is just due to its large heat of hydration. On exposure to moist air, or we can say that on exposure to air, all alkali metal get tarnished except lithium. Other alkali metal get tarnished very quickly. Why it happened actually? Alkali metals are very reactive. They will react with the gases which are present in the air. For example, they will form oxide or hydroxide as well as carbonate. So due to the formation of layer of this metal oxide or metal hydroxide or carbonate on the surface, metal get tarnished when it is placed in the air. Reactivity towards water. Alkali metals decompose water with the evolution of hydrogen. Lithium decomposes water slowly, whereas sodium reacts with water quickly, and potassium, rubidium, and cesium react with water vigorously. The decomposition is highly exothermic, and the evolved hydrogen sometimes inflames, it catches fire. And why it is happening that when we are moving down the group, the reactivity towards water increases? Because we know that when we move down the group, the electropositive character of alkali metal increases. So as they are highly reactive, we have already discussed, they are very reactive when they are kept in air, because they will react with the gases which are present in the air, and they will react with moisture also vigorously with water. So that's why your alkali metals are kept under kerosene oil. Reaction of alkali metals with oxygen. Alkali metals have strong affinity towards oxygen. Lithium forms monoxide, sodium forms peroxide, whereas the other metals, that is your potassium, rubidium, and cesium, form superoxide. You can see the reactions as well. Now, why it happened? Why this is the case that lithium is forming monoxide, sodium forming peroxide, and other metals are forming superoxide? The basic fact is this, that the cation with strong electrical field around it is stabilized by an anion with strong field, and a cation with weak field is stabilized by an anion with weak field. Or simply what we can say, that a small cation can be stabilized by a small anion, and a large cation can be stabilized by a large anion. So as the size of lithium ion is small, so it has strong positive field around it, so it can stabilize a small anion, which is your oxide ion, and form monoxide. Whereas your potassium, rubidium, cesium ion, their size is big, so they can be stabilized by superoxide ions as well. And sodium ion, its size is intermediate, means more than lithium ion but less than that of your potassium, rubidium, and cesium. So it will form peroxide. So students, revise the topic, and thank you so much.